this channel. On this channel we discuss about physics and try to learn its various concepts. So in this particular session, we are going to learn about average velocity, and we will be also discussing about average speed. So let us begin our discussion with average velocity. So what is average velocity? It is a parameter which one of the parameters which quantifies the motion. So in a previous video we saw that displacement and distance are two of the parameters which quantify motion. What do we mean by quantifying? By quantifying we mean that we tell that how much the motion has progressed, how much something has moved, or in this case of average velocity it tells how fast. So how fast, if we want to tell that at what rate the particle's position is changing with time, then we say that, in other words, we are asking that how fast the particle is moving. So average velocity is one of the ways of quantifying the motion. So how fast is related to how far, and how far is related to displacement. Okay, so here we see that mathematically, so this is the V average, is the symbol of the average velocity, and it is a ratio of two quantities. So in the numerator we have xf minus xi. xf is the position of the particle in question at time tf, and xi is the position of the particle at some initial time ti. So in numerator xf minus xi is the displacement, and in denominator tf minus ti is the total time taken so that the particle is displaced by this quantity. So in effect the average velocity is displacement over time taken, right? Okay, so as we have discussed previously that displacement is a vector quantity. This displacement is a vector quantity. Since average velocity is a ratio between displacement and time, and since displacement is a vector, therefore average velocity is also a vector quantity. That means in order to completely specify the vector, we need to find out its magnitude as well as the direction in which the particle is moving. Its unit, as may be clear from the equation here, so its unit is meters per second. So you see the unit of displacement we discussed in a previous video, meter. Unit of time is of course second. So since it is a ratio between displacement and time, so its unit is meter per second. So this is the mathematical way of finding out the average velocity. Graphs, on the other hand, are another way, a very common and effective way to describe motion. So let us see this with an example. So here we have used two axes, the vertical axis. On this vertical axis, what we have shown, on this vertical axis we have shown the particle's position. That means we have assumed the particle is moving along the x-axis. So here is the origin, and all the positions above this origin are towards plus x direction, and all the positions below this origin are towards minus x direction, and on the horizontal axis we have put down the values of time. So here we have considered three here we have considered three different instants of time. So what is happening, this graph is telling us, this plot is telling us that at time t is equal to 0, the particle is at plus 3 meter. Okay, at time, you see, at time t is equal to 0, the particle is at plus 3 meter. At time t is equal to 3, the particle is at x is equal to 0. That means it is passing through the origin. And at time t is equal to 7, the particle is actually at minus 3 meter. Okay, so you see, although and this is called an xt graph. So you see, don't confuse the don't get confused by seeing the shape of this curve. Don't think that the particle actually moves along this path. No, the particle is moving along a straight line, and that too on the x-axis. In particular, in this case, the particle is moving from plus 3 meter towards minus 3 meter. So if we try to plot this on an x-axis, so if this is this is 0, minus 1, minus 2, minus 3, and here, okay, let me draw here. Okay, so let us plot the x-axis here. This is the origin, 1, 2, 3, and so on, minus 1, minus 2, minus 3, and so on. So this is the x. Now after looking at this graph, the information in this graph, we are trying to visualize the motion on an x-axis, the actual motion. So at t is equal to 0, the particle is at here, x is equal to plus 3. Okay, this is at t is equal to 0. At t is equal to 3, the particle is at here. This is t is equal to 3 second, at 0 second. Okay, and at t is equal to 7 second, the particle is at x is equal to minus 3 meter here. This is at t is equal to 7 second. So the particle is moving in this direction. Okay, so from right towards left. And we have this, while discussing displacement, we have seen that in our convention, if in a straight line motion, if the particle is moving, if in a horizontal straight line motion, if the particle is moving from right to left, the displacement is negative. So here the total displacement is, so here xf, let me draw. Okay, we have, so okay, let me write down here. Okay, so here what will be the average velocity? Average velocity will be, you see, average velocity will be xf minus xi upon tf minus ti. What is xf? Xf is equal to, at t is equal to 7 second, xf is equal to minus 3, right? Xf is equal to minus 3. Xi is equal to, of course, plus 3. Okay, xi is equal to plus 3, and tf is equal to 7 second. So these are meters. This is second, and ti is of course 0 second. So it is minus 6 meter by 7 second Therefore V average is minus 6 by 7 meter per second. Okay, so that is how we can draw information by looking at the graph, at the xt graph. Okay, this is of course a straight line motion. So as we said previously, that it is an example of x versus t graph. Okay, we have already mentioned this point. Now another thing is that the average velocity is the slope of the curve. You can see, if you have studied mathematics, you also know that this kind of equation is the equation of a straight line. Okay, so you see here, if we want to find out V average, that means the average velocity between TF and TI, where TF is 7 second and TI is 0 second, what we do, we take these 2 points. So this is the point of, so let me now just erase these things. Okay, sorry, one moment. Okay, fine. So this is the, let me now erase it. Okay, I'm just erasing these things. Okay, sorry. Yeah, fine. So now we take these 2 points. This is the point at t, initial point Ti, and this is Tf. So we draw a straight line connecting these two, and the average velocity will be the slope of this line. What will be the slope? We have this coordinate is this is 0, 3, and this is 7, minus 3, right? So the slope will be minus 3, 7, minus 0. So I am not discussing how we are calculating the slope here. I hope you all know how do we calculate the slope. So the slope here is minus 9/7. So as we have said that the average velocity is the slope of the curve. So see, average velocity is minus 9/7. Of course the unit is meter per second. Okay, fine. Another point is that V average and displacement have the same sign always. How do we know it? We have just seen, this is in an example, that you see the displacement here is negative. That means in our example, the particle is moving from right to left on an horizontal axis. That's why the displacement is negative, and as a result the average velocity is also negative. Another thing is that since average velocity is the ratio of displacement and time taken, and since time, the difference of time is always positive, so the sign of this quantity is not going to make any difference to the sign of average velocity. So the only way that the sign of average velocity is related to this ratio is through the sign of displacement. Okay, fine. So whatever is the sign of displacement, that same sign will be held by the average velocity also. Fine. So this is all about displacement. Of course we are going to discuss some of the numerical problems also, but before moving to the numerical problems, it is essential to discuss about another related concept. So this is average speed, another concept. So this is again one of the parameters which tells us how fast the particle is moving. Okay, it also quantifies the motion. Right. So its mathematical formula is total distance by the time taken to cover that total distance. We have seen that total distance may or may not be same as the magnitude of the displacement. It is some of the students are confused that distance is always the magnitude of displacement. That is not always true. Okay, for example, if a particle moves from here to here and then comes back here and stops, so the total distance covered will be this distance, that's d1, plus this distance d2. So total distance will be d1 plus d2, but the displacement will be this quantity only. So that is this is xf, for example, this is xi, for example. So you see, displacement and distance are not same always. Okay, displacement and distance will be same only in cases like, for example, if the particle starts here and stops here. So in this case, distance and displacement are same. I hope you understood the concept. Now this distance does not have any sign. It is always a magnitude. As a result, average speed is always positive. Okay, fine. So we have already said that it is another way of describing how fast a particle is moving. And no algebraic sign because there is no direction involved. As we have mentioned, since displacement and distance are different from each other, as a result, average speed and average velocity can be quite different from each other. Now let us try to put our concept in use in solving a practical example. So the question here is, if you are driving a car at, let us say, 90 kilometers per hour, how far do you move while your eyes shut for 0.50 seconds during a hard sneeze? Okay, so this is basically, in this question, basically we are being asked the how far question. So we have to distinguish that whether this how far, there are two parameters which tell us how far. They are displacement and distance. We have just seen that they can be different from each other. Let us try to find out whether they are same or different, which quantity is the relevant quantity here. Here you see, nothing of that sort has been specifically said that the car is going like this, then this, then this. So something is not there. It is just saying that we can assume here that the car is going on a straight line motion. Okay, and while sneezing, when you are sneezing during that period also, the car continues on the same straight line path. Okay, so now it does not make any difference whether we consider distance or displacement in this case. Okay, so now the question is, we have to find out how far. We have to find out distance or displacement. So let us say that we are going to find out distance. So for our purpose, we consider this as average speed. So now we know that average speed as average. So one moment. So that we have written already here. So this question is basically asking the displacement or distance or distance. Fine. The car displacement or distance of the car in distance traveled by the car in 0.50 second. If its average velocity or average speed is this one, 90 kilometers per hour. That data is given already in the problem. So we know that the average velocity is displacement over the time taken, Now so from this formula, multiplying both sides by delta t, so we get this equation, this expression: displacement is equal to average velocity multiplied by delta t. So we put average velocity, we already know 90 kilometers per hour, and the time taken we want to find out the distance that the car travels during this 0.50 second. So this delta t becomes 0.50. So now the problem reduces from this point. The problem is only mathematical. So here we have, in this step, we have converted 90 kilometer to meter. So you know that 1 kilometer is equal to 1000 meter. Therefore 90 km is equal to 90,000 meter. That's it. That's the thing we have written here. So this 90 kilometer per hour becomes 90,000 meter per hour. Now this 0.50 second, we are trying to convert we are trying to convert this to hours, so that this hours get reduced, this hour gets cancelled out. So you know that in 1 hour there are 3600 seconds. So this quantity that we have multiplied its magnitude is actually 1. So the amount of time in 1 hour and the amount of time in 3600 seconds are same. So that's why the magnitude is 1. So in problems like this, we can always use such parameters for multiplication, so that we can easily convert from between the units. Okay, and since its magnitude is 1, multiplying the values by this with this quantity does not make any difference. Okay, so these are called unit multipliers. They are often used for unit conversion. Okay, so this actually reduces to 12.5 meter. Okay, so the required displacement is 12.5 meter, or as the question statement says, that how far the car moves during that 0.50 second of time. So in that amount of time, the car moves by a distance of, or displacement of, 12.5 meter. So that is one of the example, very simple example, that we have just discussed about distance or displacement. We are using the terms distance and displacement interchangeably in the context of this particular example, because in this particular example there is no difference between the magnitude of distance and displacement. So fine. Okay, so that is the value. So I hope you have understood the concept of distance and displacement and difference between them. So see you in next video, and thanks for your patient listening.